Let's have some fun with functions, everyone. You knew that was coming. Anyway, I always start with that too, don't I? I'm going to learn. I'm not going to be a YouTube star unless I figure this out. Learning card 4, function definitions. The title down at the bottom is different. Obviously, check the description if you want a copy of this worksheet. We're up to learning card 8 if you're following along with the Mr. Hayes plan. If you're not, you've got your own numbering system. That's fine. So we're talking about functions. Very beginning, just kind of some basic stuff to make sure you've got this for your notes. We're going to add one thing on here because I forgot to add graphs. I know, you expect more. I'm sorry. Function is a relation where, or rule where, each input has exactly one output. Now they may say it something a little fancier. Each element in the domain maps to one in the only one in the range. So tweak it for what you're doing. I'm comfortable having input and output right now, because you, my students, know that input and output is domain and range, as evidenced by your last quiz. So anyway, this is just primarily some examples of what functions are and what functions aren't. I'll give you some ideas. So when you're looking back at this 2, 3 months from now, 2 years from now when you're in Algebra 2, you can be like, oh yeah, it's that. So if we have a number map here, we've got 2 sets. Let's say we've got 4, 10, 17, and -8. It can be whatever. I'm just making these up. To be honest, I had a little bit of a hard time getting a text box nicely over the oval, and I was in a bit of a rush. And let's say these go to, so those are my outputs. Now, if this is going to work, it's interesting. You can say have as many outputs as you want, as long as it's no more than 4. And then, I don't know, pick some numbers, -7, 23, 13, 10. It's going to be a function if each one of these inputs go to exactly one of the outputs. It doesn't have to be a cross. You can cross the streams. I know it's not, well, actually it worked out good in Ghostbusters. But again, each input goes to a unique output. They could be all the same ones. If you wanted to, don't get mad at me. I'm going to go undo this here in a second. But if you wanted to, you could do something fun like this. And this is, the table is going to do something like this. You could do it like that. Again, -8's going to 13, the 17 is going to 13. It doesn't matter that they're going to the same one. It just matters that they're going to one. Just like going to a restaurant. You can go, multiple people can go to the same restaurant. You can't go to 2 restaurants at the same time. So let me put it back to where it was. There we go. On the table, same idea. Now, is there any look through your inputs? As I look through my inputs, is there any input that happens more than once? If they're all singles, you've got a function, because nothing, remember, one input, one output. So if you only have inputs happening once, there's only one place it can go. However, in this case here, I've got a 2 and I have a 2. And somebody, when I was doing this in class earlier today, said it really well. She said, the same input, that's not why in same, Mr. Hayes. I got a little excited there. The same input goes to, gets mapped to, I think is how she said it, the same output. So we're okay. I like that. I like the same input, same output. That was a good way to say it. So yeah, 2 happens twice, but they both end up at 5, so it doesn't matter. That's the nice thing about that. Domain, student ID numbers, range, last name of student. Why is this a function? Student IDs, ID numbers, are unique to the student. Let's say each, that'd be better. See, every time you do this, you do it a little differently. It's kind of nice that way. I don't have a script, I'm sorry. So each ID number is unique to each student. So student ID numbers are unique to each student, yeah. And so because of that, everybody has one. So it works. Non-functions. So again, we've got our map here. Maybe we've got 4, 3, -6, 10, 13, 19. Oh, let's say -20 maybe. If the domain numbers actually ever, if they're ever outnumbered by the range, that's a good sign too. Like here, 4 goes to 10, 4 goes to 13. That's the time where you have issues. 4 is being mapped to 10 and 13. There's no, or multiple outputs, let's put it that way. And you only need to have one example of it. And that's the thing too. Just remember, to run a function, you just need one bad input. It's kind of like, well, yeah. So I mean, it's if one happens, it doesn't matter. You can stop. It's kind of nice. When you get into geometry, you're gonna have something called counter examples, and that'll be the case there too. So as we look through our input list, we're like, oh, -2. That looks iffy. Where's -2 end up? 7. Oops. It's going to 2 different places. -2 has 2 outputs. Not a function. And then for the last one, domain of it. So again, here, last name of student. So if I type in the last name of student, how many ID numbers am I going to get out? Some students share last names or have the same last name. Some students have. So if you type in a last name, Garcia, Smith, Chen, whatever is a popular last name in your locale, what would end up happening is you get all the ID numbers for that. So all of them, oops, forgot the word of. Sorry, I'm less than my enthusiastic self. It's Friday, end of the week. So all of them will let's do this. It will kind of like all of their ID numbers will be listed under their last name or under the same name. I like that. So anyway, there we go. So just some basics. Now, if you flip the card over, maybe make an arrow on it. Just a couple of things. As I said, I forgot to give you guys a graphical interface of this. Again, remember, pause where you need to. So if we're going to do a function and non-function, biggest thing in terms of the graph, and I'm not going to use the test description because we're trying to get away from that because we found that kids just rely on that too much. So if you're a teacher and you'd like to talk about that particular test of a particular line that you check on graphs, you'll need to add that in. I'm going to warn you ahead of time. So remember, input is your x value. That's your domain area. And your range, or your outputs, come here from y. And so if I have my graph here, it can be any sort of graph. Let's say something like that. And I know if you're a teacher who's looking for that particular test, what I'm going to do is going to look a lot like that, but I'm just not going to name it. As I go through this, every x value is an input. And so you're going to look for your y value. And so if I'm going to look for my input, you're going to go to the graph to hit your y value. So input, output, input, output, input, output, input, output, input, output, input, output. So you go over to the x value and you go down or up to the y value, depending upon where you're at. And so as you go through and do that, notice there's only one place for each of these inputs to go. So that makes that a function. An example of a not a function would be something basically the graph comes back upon itself. Kind of like backs up is the best way I can say it. And when you go through and look at this, and again, look like this, there's all bunch of sorts of different things. But again, the thing is that so if I go here to 0, how many outputs do I have for an x value of 0? I go up and I go down. There's 2, one there, one there. If I go out here, let's say approximately, out here, how many outputs do I have for this x value? I go up, there's 1, I go down, there's 2. Okay, so this is my input, and it's going to 2 outputs. And that's why it doesn't work as a function. So anyway, flip it back over, we're done. I'll get this uploaded for y'all. So please continue to ask questions. Hope this helps. We'll talk to you soon.